In this video, I'll be looking at several integrals that involve exponential functions. First, let's remind ourselves the integral of e to the x dx is just e to the x plus c. And for any a greater than 0, if I have the integral of a to the x dx, that is a to the x over natural log of a plus c. So let's look at our first example. Here I have e to the x square root of 1 plus e to the x. By substitution, I really want my u to be all that crap underneath the radical and hope the derivative is sitting on the outside. So let's do that. My u is 1 plus e to the x. The du is e to the x dx, which is perfect because that's what I have on the outside. So that all gets wrapped up in my du. So this integral becomes the integral of the square root of u du, or u to the 1/2. Now I can use the power rule, add 1, divide by what I get, or multiply by its inverse. So I have 2/3 u to the 3/2 plus c, and substitute my u back in because that was just a helper and nobody knows what that u is but me. So I get 2/3, oh, I left the power off, that should be 2/3 to the 3/2. I'll fix that in production. Let's try this one, 3x squared e to the 2x cubed. Again, the stuff on the inside is that 2x cubed. It's inside the power of the e. And I'm going to ignore that 3x squared for right now. I will let u equal 2x cubed. The derivative is 6x squared dx. Now I don't have 6x squared dx, but I do have 3x squared dx. So I divide both sides by 1/2, then I have what I need to fill out my integral. So plugging in my u, I have 1/2 e to the u. Integral of e to the u is e to the u plus c, and I still have the 1/2 out front. Then I'm going to plug my u back in, which was, what was it again? 2x cubed. So my final answer is 1/2 e to the 2x cubed plus c. A tri-word problem. And it's economics, which is my favorite field. Oh wait, no it's not. The price demand function represents the quantity demanded as a function of price. Find the price demand function p of x for a particular brand of toothpaste at Kinney's when the demand is 50 tubes per week at $2.35 per tube. Given that the marginal price demand function p prime of x for x number of tubes per week is given by p prime of x is negative 0.015 e to the negative 0.01x. And if Kinney wants to sell 100 tubes per week, what should the price be? Well, the first thing we want to do is figure out what p of x is. And since we're given the derivative of p of x, we're going to integrate it. So I have the integral of negative 0.015 e to the negative 0.01x. Since my exponent is just linear, I'm not going to bother doing the u sub. I'm just going to divide by this negative 0.01 to get the indefinite integral. Simplifying this, I get 1.5 e to the negative 0.01x plus c. We were given that p of 50 equals 235. So I'm going to use that to figure out what my c is. I plug in 235 and 50 for my x, which tells me c is equal to 235 minus 1.5 e to the negative 0.5. And yes, I'm leaving it like that. I don't like to change into decimals until I have to. So that means p of x is 1.5. You can read that. I'm not going to read all that. Here's my p of x. Ta-da! The next thing they asked us is if Kinney wants to sell 100 tubes, what should the price be? P of 100 is 1.5. I just plugged in the 100. Then I stuck it into Excel and got the answer of $1.99. So if Kinney wants to sell 100 tubes per week, they're going to have to sell it for $1.99. I don't think I've ever seen a tube of toothpaste in the last year for $1.99. This might be an old problem. Anyway, let's look at another one. I have critters in my basement, and their growth rate is q of t equals 3 to the t, where t is given in days and q of t is given in critters. If when I noticed the infestation there were 20 critters, find the function q of t that gives the number of critters in my basement at any time t. And how many critters do I have after 3 days? Let's work on this. If I know that q of t is 3 to the t, I need to figure out what big Q of t is by integrating. I have the integral of 3 to the t dt, which we know is 3 to the t over natural log of 3 plus c. Since I know that we started with 20 critters, that means q of 0 is 20. Plug that in. I see that c is equal to about 19. So I can plug that in to get my q of t is equal to 3 to the t over natural log of 3 plus 19. My next question is, how many critters do I have after 3 days? So plugging 3 in, I get 44. It is definitely time to move. In the summer, the number of black flies in Canton increase at a rate of g of t equal to 2e to the 0.02t, where t is given in days. If we started with 100 flies, how many black flies do we have after 10 days? Same sort of problem, but I'm going to do this a little bit differently. By the fundamental theorem of calculus, we know that the integral from 0 to 10 of 2e to the 0.02t dt is the antiderivative q of 10 minus q of 0. Bring the q of 0 over. I know q of 0 was 100. And I integrate this by dividing by the coefficient. Again, this is a linear exponential. So I divide by 0.02. I want to integrate from 0 to 10. When simplified gives me 122 black flies. So when we're integrating these exponential functions, if you just have a linear exponent, it's pretty straightforward to integrate them. If you have a bunch of gooch up there, like the x squareds and the x cubed or other shit, you're going to hope the derivative is sitting out front of this thing. We'll do some more problems in class, some more word problems, because I know how much everyone loves word problems. And that's all for now.